Okay, part 2, number 18. We're just going to add f plus h. So 2x minus 1 plus h, which is 1/2 x minus 4. So 2x plus 1/2 x is 2.5 x. You could also put 5/2 x, doesn't make a difference, minus 5. -4 plus -1 is -5. Number 19, we're going to subtract f minus g. So that's 2x minus 1. Parentheses don't matter here. But they do matter for this part because we're distributing the negative side. When we distribute that, it's going to become negative, negative, positive. 2x minus 1 minus x squared minus 2x plus 3. Put the negative x squared first, then go in descending order. We have 2x minus 2x, so they cancel. And then we have 3 minus 1, which is 2. That's it. Now we're going to plug 3 into f. 2 times 3 minus 1. Now we're going to subtract h, filling in -2. Half of -2 minus 4. 2 times 3 is 6, minus 1 is 5, minus whatever this ends up being. Half of -2 is -1, minus 4. So again, it's -1 minus 4 is -5. And we do 5, subtract the negative, we get 5 plus 5, which is 10. So g over f. Here, all we're doing quite simply is just writing x squared plus 2x minus 3 over 2x minus 1. And then we have to go one step further. So that's the first part of our answer. Next part of our answer is 2x minus 1 equals 0. X equals 1/2. So we add on to our answer and say that x cannot equal 1/2. That's a two-part answer. F times g. So we're going to do 2x minus 1 times g, which is x squared plus 2x minus 3. We're going to take the 2x times each of the terms and the -1 times each of the terms. So that will give us 2x cubed plus 4x squared minus 6x. Now the -1. Minus x squared minus 2x plus 3. X cubed. 4x squared minus x squared is plus 3x squared. Negative 6x minus 2x is negative 8x. And then plus 3. So now we're going to plug -1 into f. So 2 times -1 minus 1 plus 3 squared plus 2 times 3 minus 3. 2 times -1 is -2 minus 1 is -3 plus 9 plus -3 minus 9 is 6. 6 plus 6 is 12. Minus 3 is 9. f of g of x. Now remember, this is where you take g and plug it into f. So what's f again? 2x minus 1. So we start to write that and take the x out, and now we're going to plug g in, which is x squared plus 2x minus 3. There's my x. I took x out and put that in. Substitution. So 2x minus 1. Distribute my 2. Not to the 1, because the negative 1 is outside the parentheses. And now I just simply have 2x squared plus 4x minus 7. G of f of x. This is just a different way of writing it. So we're going to plug f into g. So again, g was x squared. So we're going to do 2x minus 1 squared plus 2 times 2x minus 1. That is x. Minus 3. Now, 2x minus 1 you can take off to the side and FOIL, or you can use a shortcut. Square the first term. Multiply negative 1 times 2x. Negative 2x and double. Negative 4x. Square the last term. Plus 1. Now we're going to send the 2 in. Plus 4x. Minus 2 and then minus 3 just tags along. The 4x squared is going to hang out. Minus 4x plus 4x cancels. And then I just have 1 minus 2 minus 3. 1 minus 2 is negative 1. Minus 3 is minus 4. And last, we're going to plug 2. This time we're going to plug 2 in f. And whatever new number we get, plug that into g. So again, f is 2x minus 1. So 2 times 2 minus 1, and see what we get. 2 times 2 is 4, minus 1 is 3. Now we're going to plug that into g. So x squared plus 2 times x minus 3. That's 9 plus 6 minus 3. 9 and 6 is 15, minus 3 is 12. And there's our answer. Okay, some inverses. To find the inverse, we switch the x and the y and then solve for y. So I'm going to do that down here just for room. So first off, x equals 1/3 y, plus 2. Subtract 2 from both sides, x minus 2 equals 1/3 y. To get rid of the 1/3, I'm going to multiply by 3, both sides. Which gives me y equals 3x minus 6. Or 3 parentheses x minus 2. So I'm going to use my calculator here and put in the first one. Y equals 1 divided by 3. Do not put 0.3 because you're getting an approximation. Put divided by 3. X plus 2. And just go ahead and get some numbers there. And you can look. We're going to use multiples of 3. So like negative 3, 1, 0, 2, 3, 3. Negative 3, 1, 0, 2, 3, 3. That gives the points of the graph. And we can compare and see if that looks like what we should have. And it does. Now remember, the easy thing to do here is just switch. So 1, negative 3 And now we have graphed the inverse. Remember, use your calculator, just get some points from the first one, and then flip them. Find the domain and range of the inverse. Remember, we're not just listing these, because they go on forever. Those are just the points I picked. So the domain is negative infinity to infinity, and the range, negative infinity to infinity. How far left? How far right? How far down? How far up? Is the inverse a function? Yes, it is. It's a linear function. 28. Okay, now a lot of room here. So x equals y squared plus 1. Subtract the 1, x minus 1 equals y squared. To make it just y, we square root both sides. So y, or the inverse function, is the square root of x minus 1. Remember, whenever you do this, you must put plus or minus in front, so we get the full effect. Use the calculator. X squared plus 1, right? Put that in there. X squared plus 1. And then get some points. It's going to be our classic parabola, just moved up 1. That's all. So we're going to have points like negative 3, 10, negative 2, 5, negative 1, 2, 0, 1, 1, 2, 3, 2, 5, 3, 10. For the inverse, we can go right now. 10, negative 3, 5, negative 2, 2, negative 1, 1, 0, 2, 1, 5, 2, and 3, 10. Sorry, 10, 3. I'm doing so well. So let's graph those. Negative 3, 10, right up here. Negative 2, 5. Negative 1, 2. 0, 1. So you can tell this is just our same one, just heightened up one spot. So we're going to have a matching one here. We're going to have a matching one here. And we're going to have a matching one at 3, 10. So there's our parabola. Now we're going to graph the other one. 10, negative 3. 5, negative 2. 1, 0. 2, 1. Sorry, 2, negative 1. 1, 0. And then 2, 1 again. 5, 2. And then 10, 3. Which right off the bat tells us we don't have a function because we have multiple outputs for one input. So the domain of our inverse, how far left does it go? 1, inclusive. To the right forever. How low does it go? Negative infinity. How high does it go? Positive infinity. Is the inverse function? No. Flumps the vertical line test. 2x cubed minus 3. Start. Whoa, did not mean to do that. Start up here, get some of it out of the way. Y equals 2x cubed minus 3. X equals 2y cubed minus 3. Add 3 to both sides. X plus 3 equals 2y cubed. Divide by 2. And you get x plus 3 over 2 equals y cubed. Then we take the cube root of both sides, which leaves us with the cube root of x plus 3 over 2. it gets to be a mess, there's not a lot of room. But again, just let's put this in our calculator. So I'm going to show that to you. I'm just going to put it in mine. 2x caret 3 minus 3. So what's that going to do? It's going to move the snake, the cubic function, down 3. That's what's going to make it climb a little bit faster, because it's got a 2 in front of it. So let's go to our graph, our table. A lot of these we won't even be able to get because they climb so fast. -2, -19. We're not going to be able to graph that. -1, -5. 0, -3. 1, -1. And 2, 13 will be close. Yes, like that. So -2, 19 is going to be way down here somewhere, even further. -1, -5 is right here. 0, -3, 1, -1, and 2, 13 is going to be somewhere up here. So we can kind of get, even though it's off, it's going to be pretty slender. That snake is just a little slightly bent. It's not as curled as other ones we've seen. Then just flip them. -19, -2, -5, -1, -3, 0, -1, +1, 13, 2. Again, we're not going to be able to do a lot of these. -19, -2 is going to be somewhere off the chart, further out that way. -5, -1, -3, 0, -1, +1, and 13, 2. Be off kind of somewhere out there. Pretty close. So the domain and range of the inverse. Domain, left forever, right forever. Range, how low does it go? Forever going down a little bit, and forever going up a little bit. Is it a function? Yes, it is. $30. Not sure what that said. Oh, it's just a radical square root of x plus 2. So this one is simply our classic square root, which looks something like that, but it's just lifted up 2 spots. Let me show you that again with actually some points. So we know it's 0, 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. So there is our square root. All we do is move this thing up 2 spots. That's all that happens. So now we have 0, 2. Instead of 1, 1, we have 1, 3. Instead of 4, 2, we have 4, 4. And instead of 9, 3, we have 9, 5. And then we're just going to reverse those. 2, 0, 3, 1, 4, 4, and 5, 9. So 2, 0, 3, 1, 4, 4, and 5, 9. But something's wrong here. We know that the inverse of a square root is a quadratic. So let's see what it is. Y equals square root of x plus 2. For room space, I'm just going to jump right to the switching. X equals square root of y plus 2. X plus 2 equals square root of y. Then we square both sides and get y, or the inverse function here, y, same thing, is equal to x plus 2 squared. So that's our classic parabola, just shifted over 2 places to the left. So what we do is we just put that into our calculator, parentheses, x plus 2, close parentheses, squared, and then graph it and see what it looks like. somewhere. I start off with a positive 2, so this should be minus 2 right here. Let's just erase that. And so therefore, this should be x minus 2, which makes more sense because look, this is shifted over to the right. So we need to get some more points here, like negative 1, 1. And maybe 0, 4. Sorry, I forgot to change it into my calculator to minus 2, so that's going to be negative 1, 9 and 0, 4. Which makes more sense. So it's the same parabola, just shifted over 2 places to the right. So the domain, since the parabola is negative infinity to positive infinity, left and right forever. How low does it go? It hits the axis at 0 and goes up to positive infinity forever. Is it a function? Yes. It's a parabola. Okay, verify that they are inverse using composition functions. So when we plug them both in to each other, we should get x for both of them. So let's see. First off, we're going to take this and put it right here. So 2/3 of 3x plus 15 over 2 minus 5. So we're going to distribute this, multiply, and get 6x top times top plus 30 over 6 minus 5. Well, I can write that as 6x over 6 plus 30 over 6 minus 5. 6x over 6 is 1x. 30 over 6 is 5, and 5 minus 5 is 0, so this comes out to be x. Now, I'm going to plug this in there. So I have 3 times 2/3 x minus 5 plus 15 all over 2. So I'm going to set the 3 in first, and the 3 is going to cancel, give me 2x minus 15 plus 15 all over 2. Well, those are going to cancel, leave me 2x over x, and 2x over 2, which is simply x. So the answer is yes, they are inverses. 2 more and we are finished. So we're going to plop this in here, as nasty as it looks. So the square root of 2x plus 5. But it's not that bad, because what's happening to it? It's being squared, minus 5 over 2. Well, this squaring gets rid of that, so all we have on the top is really 2x plus 5 minus 5 over 2. The 5's cancel, just like the 15s just did. And I have 2x over 2, which cancels, leaving me x. So that way works. Let's try the other direction. The square root of 2 times x squared minus 5 over 2 plus 5. All that underneath the radical. Well, I want to send in the 2, so those are going to cancel, which leaves me with x squared minus 5 plus 5. The 5's cancel, which leaves me square root of x squared, which is x. And so we get, again, yes, they are inverses. So we're going to go 3 for 3. Let's see what happens. So I'm going to plug in to x cubed plus 5, the cube root of x minus 5. This undoes that. So I get x minus 5 plus 5 cancels. I get x. Oh, we're almost there. Now let's go the other direction. Cube root of x cubed plus 5 minus 5. Well, really no reason for the parentheses. So the 5's cancel, which leaves me with the cube root of x cubed, which cancels, leaving me x. So we went 3 for 3. They are also inverses of one another.